All right, good morning, everybody. Let's go ahead and get started with multiplying, dividing, estimating with scientific notation, okay? So let's take a look at some of these and say whether this is true or not. So just by looking at this first one here, this is 10 to the 5th, 10 to the 4th, and since we're multiplying, we're going to add the exponents. But 5 plus 4 does not equal 20. So this is false. Okay? Similarly here, we're dividing 7 divided by 2, that's correct. And then 10 to the 6th over 10 to the 4th, since we're dividing, that becomes subtraction. Yep, that's correct. 8.4 times 10 to the 3rd times 2. Okay, so this is a multiplication, so okay, this is good, right? We can combine these two, but I don't like this right here. I don't know why they're multiplying the exponent by 2. That's false, bruh. Okay? So use the table to answer questions about different creatures on the planet. Be prepared to explain your reasoning. Okay. So this right here is how many there are, and this is how much one of these, what the mass is. Okay, so how much it weighs. I'm just gonna remove the zoo and just leave it as plankton. Which creature is the least numerous, meaning which one is the least amount that exists? So it's the one with the smallest exponent. Blue whales. Oopsie. Estimate how many times more ants there are. Okay, so what they're asking us is they want us to divide. Okay, so it's going to be 5 times 10 to the 16th over 4.7 times 10 to the 3rd. Now, I can easily do the right side. I can do 10 to the 16th over 10 to the 3rd because we just subtract the exponents. That's 10 to the 13th. But then you're going to need a calculator for this, for sure. 5 divided by 4.7. Oopsie. 5 divided by 4.7. Oh, que la chiflada. 5 divided by 4.7. Okay. That's 1.06 times 10 to the 3rd. So how many times more ants? 1.06 times 10 to the 13th. Which creature is the least massive? This means which one weighs the least. And then if we look at which one has the smallest exponent, this is technically the smallest exponent, okay? Bacteria. And it's smallest because it's more negative. How many more times more massive a human is? So let's look at a human. It's 6.2 times 10 to the 1st. We're going to divide that by 1 times 10 to the negative 12. Since we're dividing exponents, we're going to subtract them, right? So what's 1 minus a negative 12? Well, that's the same thing as 1 plus 12, which is 13. So it's going to be 6.2 times 10 to the 13th times. Which is more massive, the total mass of all the humans or the total mass of all the ants? So they're asking us, if you were to multiply these two, let me use a highlighter. If you were to multiply these two, and you were to multiply these two, which one's bigger? Well, 7.5 times 6.2 is 45. And then 10 to the 9 times 10 to the 1 is 10 to the 10th. So that's the total mass for humans, okay? And if we look at the ants, that's going to be, okay, let's do it over here. 5 times 3, that's 15, times 10 to the, well, that's 16 and a negative 6. We add those, so that's 10 to the 10th. So which one's bigger? Yep, humans, right? Humans, there's more mass for humans. But how many times more? If it's 45 compared to 15. You would divide, right? 45 by 15, and you'll find that it's 3 times. Which is more massive, the total mass of all the krill or the total mass of all the blue whales? So if you didn't know, krill is what whales eat, okay? So here's the krill. Where are the blue whales at? Right here. So let's do it on the left side. 4.7. Let me write this out. 4.7 times 1.9, right? And then it's 10 to the third times 10 to the fifth. So we're going to add the exponents. That's just 10 to the eighth. So 4.7 times 1.9. Oh my God. 4.7 times 1.9. That's 8.93 times 10 to the eighth. And then we're going to multiply. Yep, that's for the blue whales. And then we're going to do the same thing with the krill. 10 to the 14th and 10 to the negative 4th is going to be 10 to the 10th. And already I can tell that it's going to be bigger because there's already a bigger exponent. 7.8 times 4.86. Oh my God. 7.8 times 4.86 is 37.978. 37.908 times 10. So already, right, we can tell that our Antarctic krill is bigger. Antarctic krill. And if we were to divide, right, we're going to do 37.908 times 10 to the 10th over 8.93 times 10 to the 8th. Now 10 to the 10th over 10 to the 8th, that's going to be a 10 squared. And then 37.908 divided by 8.93. Remember, this is all estimation, is 4.25 times 10 squared. So that's how many times bigger, or how many more times krill there are as opposed to blue whales. This is good. This means there's more food for whales than there are for krill. The blue whales will hopefully never die out, but as we increase global warming, this means that our oceans become more acidic. And if you didn't know, acidity kills sea life. Ooh. So use a table to answer questions about the sun and the planets, the solar system. Wow. Throwing shade here. Bruh. I'm going to throw my iPad out the window. Wow. Sorry, Pluto. You know what? I'm gonna get a tattoo of Pluto at some point. Did you guys know I'm actually getting a sleeve done right now? If you didn't know, damn, I'm missing out. Okay, so here we have a bunch of numbers, okay? We have the planet, or sorry, the object, right? Because the sun is not a planet. We have how far it is to Earth, and it's in scientific notation. We have the diameter, and if you forgot, the diameter is just how long it is from one side to the other side, okay? And we have the mass, so how much it weighs. So estimate how many Earths side by side would have the same width as the sun. So how many Earths would we have to put side by side so it would reach the sun? So what we're going to be doing is we need to figure out how many more Earths we need. So we're going to look at the diameters. Here's Earth, and here's the distance to Earth, okay? And what do you think we're going to do with those two numbers? Yup, we're going to divide. So 1.46 times 10 to the 8th over 1.28 times 10 to the 4th. So I really wish I had an on-screen calculator. I think that would be like legit. Divided by 1.28, because then you could see what I'm typing. So this comes out to be 1.14. And then I'm just gonna estimate that, times 10 to the 8 minus 4 is 4. So that's how many Earths you would need. That's about 10,000 Earths side by side. It's a lot. About how many Earths would it take to equal the mass of the sun? So we have the mass. Let me use a different color for this one. We have the mass of the Earth, and we have the mass of the sun. So what do you think we're going to do with those two? Yup, we're going to divide. We're going to do 1.989 times 10 to the 30th over 5.98 times 10 to the 24th. So I know 10 to the 30th over 10 to the 24th is going to be 10 to the 6th. And then 1.989, oh boys, 1.98, bruh, I swear to God. 1.989 divided by, I never knew I could rage at a calculator. Maybe that's why I don't like them. Gives me 0.332 times 10 to the 6th. Now, this is not in scientific notation, right? We would want to write this as 3.32 times 10 to the something. And since we're moving the decimal over once to the right, we're going to subtract 1 from the exponent. So that's going to be to the 5th. So that's how many Earths you would need. So it would weigh the same as the sun. It's ridiculous. Estimate how many times as far away from Earth the planet Neptune is compared to Venus. So we want to see how many more times is Neptune farther away than Venus. So we're going to take, let's use green, not Uranus. We're going to look at Neptune. And we're going to look at Venus as well. And we're going to divide. It's all about dividing here, okay? So if you've already caught that on, that's good. If you haven't, I'm letting you know right now. You're going to have to be dividing if you want to find how many times bigger something is. So 10 to the 9th over 10 to the 7th is 10 squared. And then 4.3 divided by 4 is equal to 1.075. 1.075 times 10 squared. That's how many times farther away. And then how many more Mercuries would it take to equal the mass of Neptune? So we're going to look at the mass of Neptune. Let me use blue. We're looking at the mass of Neptune. And we're going to look at the mass at Mercurio. Does it fit? No, I'll just make this a little bit smaller. So, I'll just make this a little bit smaller. There we go. So we're going to take 1.024 times 10 to the 26th, and we're going to divide that by 3.3 times 10 to the 23rd. 10 to the 26th over 10 to the 23rd is going to be 10 to the 3rd. We're going to divide 1.04 to, 1.024, oh my God. 1.024 divided by 3.3, can't mess that up. And that gives me 0.31, let's just round it, times 10 to the 3rd. But that's not in scientific notation. It would be 3.1 times 10 to the squared, right? Because we're moving it once to the right, so this drops by 1. Professions in the United States. Where's the best profession? GG's, they don't have it. Okay. Use the table to answer questions about professions in the United States as of 2012. So we have architects, and this tells us how many architects we have, how many artists, programmers, doctors, engineers, firefighters, blah, 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 blah. Answer the following questions about professions in the United States. Express each answer in scientific notation. Estimate how many more times more nurses there are than doctors. So let's start with black, actually. Let's just go through the colors. So here's doctors, and here's nurses. Obviously, there's more nurses than doctors, so we're going to do 3.45 times 10 to the 6th over 6.9 times 10 to the 5th. 10 to the 6th over 10 to the 5th is going to be, 10 to the 1st, or just 10. And then we're going to do 3.45. There's a lot of number crunching. 6.9. So you definitely need to have a calculator. That's 0.5 times 10 to the 1st. But we want this in scientific notation. So that's going to be, we're going to move this once over to the right. So that's going to be 5 times 10 to the 0, which is just 1. So there's 5 times more. That's funny. Estimate how much money all doctors make put together. Okay, so we're going to use red for that. Doctors, right? Yep, we're going to look at how many doctors there are and how much money they make in total. So 10 to the 5th, 10 to the 5th is just going to be 10 to the 10th. And then we're going to do 6.9 times 1.87. Yeah, 1.87. And that's 12.972. So that's how much money they make. But it's not in scientific notation. We're going to move this decimal once to the right, so that's 1.2972. But then what happens to the exponent? Are we going to make it go up or go down? If you said up, you're right, because we're moving it to the left. That's how much money they make in total. Estimate how much money all police officers make put together. Hands up, don't shoot. I should not be saying that. Here's police officers. Here's how many police officers there are and how much money they make. So, whenever I get pulled over, I always put my hands out the window because you don't know. As a person of color, you got to be careful out nowadays. 10 to the 9th, right? We add the exponents. So that's 5.7. I mean, I don't want to instill fear in y'all. 5.7 times 7.8. But you can never be too careful. 44.46 times 10 to the 9th. And then we're going to move it once to the left. So that's going to be 4.446 times 10 to the... And we're going to increase the exponent by 1. Who makes more money? All enlisted military put together or all military officers put together? Wait, that doesn't make sense. Oh, there's a difference between enlisted and officers? I guess there is. Estimate how many times more. Okay, so let's actually do this on the side here. Let's just do the math here. And I'm going to use purple because why not? So which ones are we looking at? Oh yeah, these two right here. So let's look at the first one. I know for a fact it's got both ways. It's going to be 10 to the 10th for the top one, right? Because it's 6 and 4 as the exponents of 10. And then it's going to be 1.16 times 4.38. And that gives us 5.0808 times 10 to the 10th. And then the bottom one, it's 10 to the 10th, 10 to the 10th. So that's, 10 to the 5th, 10 to the 5th. So that's 10 to the 10th times, oh, that's easy. 2.5 times 1, that's 2.5. So if you just had to look at this, they have the same exponents. So how many times bigger is 5.08 compared to 2.5? It's about twice as much, right? It's about $2 worth. Or sorry, 2 times as much. 2 times more. So the idea here for this summary is just like figuring out how to find how many times bigger one is compared to the other. And really what you're going to be doing is either dividing or multiplying if you're finding the total, right? Here we found the total. Or for some of these, we were finding the total, so we were multiplying. But when you're finding how many times more bigger, that's when you divide, okay? So switching over to the practice. Evaluate each expression, use scientific notation to express your answer. Oh my god, my tattoo is itching right now. 1.5 times 5 is 7.5. And then 10 squared, 10 to the 10th. Oh, my iPad pencil is running out. We're going to add the exponents, so that's 10 to the 12th. The next one, 4.3 divided by 3. I'm a nerd. I know that's 1.6. And then it's 10 to the negative 8 over 10 to the negative 3. So we're subtracting. And I know that a negative is a positive. So that's going to be a negative 8 plus 3 times. So that's 1.6 times 10 to the negative 5th. 5 times 4 is 20. Times 10 to the 8 plus 3 is 11. But that's not in scientific notation. We're going to have to move the decimal one to the left, which means, since we're moving it to the left, we're going to increase the exponent by 1. We're dividing here, okay? So 7.2 divided by 1.2. That's the same thing as 72 divided by 12, which I know is 6. And then 10 to the 3rd over 10 to the 5th. Well, that's going to leave me with 2 10s in the bottom, which I know I can write as negative 2, okay? How many bucket loads would it take to bucket out the world's oceans? That means if you were to use a bucket and remove water from the ocean, 1 bucket at a time. Jesus Christ. The world's ocean roughly holds this much water. So that's the total amount of water. A typical bucket holds about 20,000 cubic centimeters of water. Why would you... Okay, and there's about in a cubic kilometer. Jesus Christ. This is even confusing for me, bro. I mean, y'all. There are 10 to the 15th cubic centimeters in a cubic kilometer. So how about we figure... let's figure out how many buckets there are per cubic... Like, how many buckets would you need per cubic kilometer, okay? So let's write this as a power of 10. That's going to be 2 times 10 to the 4th, right? Because there's 4 zeros. So that's how many cubic centimeters there are per bucket. And how many cubic centimeters are there in a kilometer? There's 10 to the 15th. So it's 1 times 10 to the 15th. So we're going to divide the 2. That gives me 0.5, right? Because 1 divided by 2 is 0.5. And then 15 minus 4 is 11. But we're going to move the decimal once to the right, which means this is going to be 5 times 10 to the 10th, right? So that's how many buckets you need per kilometer, right? That's 5 followed by 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. This is how many buckets you would need. That's 50 billion buckets. Right? 50 billion buckets you would need to do just for 1 cubic kilometer. And cubic meaning, right, if you were to have a cube where each side measures 1 kilometer, that's about 0.6 of a mile. That's how many buckets you would need to remove this much water. But we need this number here, 5 times 10 to the 10th. Because now we know how many buckets there are per kilometer. What do you think we're going to do with the number of buckets per kilometer and how many cubic kilometers of water there are in the ocean? Yep, we're going to have to multiply. We're not actually dividing here. We're multiplying because we need to know the total amount of buckets. 5 times 1.4 is 9. No, not 9. 7. And then it's 10 to the 10th and 10 to the 19th. No, 9. That's 10 to the 19th buckets. That's a 7 followed by 19 zeros. That's a lot of buckets. A lot of buckets. The graph represents the closing price per share of stock for a company each day for 28 days. Okay, so first of all, a stock is just like a share of stock. Imagine you wanted to buy a company, right? You would need like okay, maybe not $1 billion. You would need some money. But maybe you don't have that type of money. Maybe you can't put in $100 billion to buy Apple. So what you do is you tell Apple, hey, can I buy like a small percentage of your company? Something like 0.0001%. And then the company's like, yeah, sure. You can pay us $53 and you will own 0.0001% of the company. And then so you pay them $53 and now you own part of Apple. And then suppose Apple comes out with the new iPhone, I don't know, X squared plus 1, right? Whatever that is. And then the company, the value of the company, people are like, oh my God, that company is going to be making so much money. So this $53 now, right, your 0.001% share of the company, it jumps up to like $60. That's what we mean by the closing price. Because the price of the company could either go up in value or lower in value. So now that one piece of paper that you bought that makes you 0.0001% owner of Apple is now worth $60. And you could sell it, and then obviously you would make $7 profit. Some people do that. But anyways, here are the prices for 28 days, okay? And just letting you know, I'm doing this with a bunch of companies right now. I bought $200 worth of stock, before we shut down school, and it went up to $256. So I made $56, but I didn't sell the stock. I kept it. And now with this coronavirus, let me actually check my phone how much it's worth right now. I know my IWE knows about this because I was telling them, my IWEs, I was telling them about how much money I was making, and now I'm losing money. Now it's at $147.39. Talk about a loss. And that makes sense, right? A lot of companies are closing down, so it makes sense that the price of companies are going down in value. So actually, just think of this as Disney stock, okay? Like Disney. So what variables represented on the horizontal axis? This is the number of days. In the first week, so that's right here, what was the stock price generally? Was the stock price generally increasing or decreasing? Was the value of the stock going up or down? It was increasing, right? During which period did the closing price of the stock decrease for at least 3 days in a row? So where did it drop in price for 3 days in a row? Right here, right? Woo! During which day period? Days 7 to 10. Should I even say this? Sure, I'll say this right now. When you're older, and if you want to invest in the stock market, this is where you want to be buying the stocks. Because obviously, they're going to go up in price. And right here, actually. They're going to go up in price. And then when do you want to sell the stock? Obviously at their peaks. Because then all of this right here, whatever this is your profit. And people do this. If you watch the movie The Wolf on Wall Street, I think, I've never seen it, but if you watch it, it'll give you a better heads up. Write an equation for the line that passes through the points. Oh, okay. So, visually, right, this is what the points would look like. Negative 8.5, 11, negative 8.5, 11. And then 5, negative 2.5, 5, negative 2.5, right, down here. So it's going to have a negative slope. Now, if we want to find the vertical change here, the vertical change is associated with the y values. If it went from 11 to negative 2.5, that's a total change of 13.5. And similarly, from negative 8.5 to 5, the total change right there is negative 13.5. Right, because that's the total difference. And since it's the same number, it's just one's positive and one's negative, that's going to be a negative 1. So I know my slope is going to be negative 1x plus something. And we need to find the starting value. The fact that it's negative 1 actually helps us out a lot. This means if the x value decreases by 5, the y value also decrease. Well, it'll increase, right? Because it's negative. It's a negative slope. It'll increase by 5. So if we take a look at this point here, 5, negative 2.5, if it goes 5 this way, it's going to go up by 5 this way. And that'll tell us what the y-intercept is. So what's negative 2.5 plus 5? It's going to be 2.5. And that's our starting value. Y equals negative 1x plus positive 2.5. Yeah, I was like, with this homework, it's really long. Explain why triangle ABC is similar to triangle CFE. Okay, so this is really way back. And the easiest way to tell if two triangles are similar is just by looking at the ratios. The ratio of ABC, right? If we take a look at this side, yeah, my pencil's dying. If we take a look at these sides, and we take a look at these sides, the slope here for the smaller triangle is 2 over 1, and the slope for the bigger triangle is 4 over 2. 2 over 1 is 2, 4 over 2 is 2. Hey, look, they're equal. That's why they're similar. Anywho, y'all, it was really nice seeing some of y'all yesterday at school. Just a reminder, every Thursday we're giving out free food, first come, first serve. So it's nice to see, some of your teachers there, okay?